Hello friends, welcome to Suresh Aggarwal's Mathematics Shortcuts. The topic of speed and time is going on, and I have put up 9 different videos in which I told you so many different short tricks to crack different models of questions. The upstream and downstream motion of boats, very important, right? And last two videos have shown how efficiently we can crack this topic. In this video, I am going to take up yet another very important and very lengthy question which troubles the students when it comes as a multiple choice question in the quantitative aptitude exams. So I am going to simplify this for you, and I am going to show you how smartness can save time and how short tricks can help crack these questions within 15 seconds of time. Yes, the question which consumes 6 to 7 minutes through traditional approaches, making all sorts of equations and solving them, will be cracked in 15 seconds. So what is the concept? The concept is finding the speed of boat, that is in still water, and finding the speed of stream under a given condition. Now what is that given condition? I will discuss that. Before that, let me tell you that this is a part of the chapter 1 of the volume 2 of our amazing book, The Ultimate Guide to Speed Maths. And this comes in the ebook form also. So if you want a copy of the e-version of our book, then you can send me a message on WhatsApp. The WhatsApp number is written here, 9896369963. All these details which I have given here, these are in the description of this video as well. So we need to understand the concept first. What type of question is this? What short trick works? And then do the application part. So I will show you the question first. See this question. Here we have a boat which goes 12 km upstream, right? So there is some distance which is D, which is upstreams. Distance up. I'll write D up. Distance upstreams. This is 12 kilometers here. And then there is some distance downstream. So distance down. This is 14 kilometer here, and the time taken is given in the question. That means let's write time here, and this time is 6 hours in the first case. Likewise, because there are two distances and a single time, so you will have one more case because two variables cannot be found out using a single condition. So what is the second condition? 15 upstream, so distance upstream 15, and 10.5, right? 10.5 downstreams. So 10.5 kilometers here. 6.5 hours. So I'll write 6.5 hours. Right? Now these are the two conditions, and we need to find the speed of boat in still water and the speed of stream. Right. So now you know the nature of the question. So I'll go back to the concept now, and we will first list down the variables and then the short trick. So I told you there are columns like distance upstreams, distance downstreams, and the time taken. These are the three columns. So if I call the distance upstream as say x and this as y and the time taken as t1, and similarly the distance y has already been taken. Okay, let's represent this as say w. We will write w here and y here. So x, y, and w and v. So these are the distances upstream, distances downstream. For covering these two, the time is t1, and for covering these two, the time is t2. Now we need to find what is the speed upstreams and speed downstreams, and then the speed of boat in still water and the speed of stream. To find the speed upstream, that means u, will use a relationship, and likewise to find the speed downstreams, that is d, we will again use some relationship derived from this matrix only. So for the first one, you need to cross multiply like this, xv, right, and then subtract the other cross product, minus yw, and in the denominator you need to go like this, vt1, and again subtract wt2. See how we are doing the cross multiplication. We have done xv minus wy and vt1 minus wt2. This will give you the speed upstreams, that is u. For finding the speed downstreams, we will have to do again the same thing, xv, right, and then minus yw again. So the numerator remains the same. In the denominator there will be a change. Now we will do xt2 minus obviously yt1. Now this is the variation in the method. So if you know how to find the upstream and downstream speed, then finding the speed of boat in still water, which okay, I can't represent it by x obviously because x is already used up here. So we will use speed in still water directly, speed in still water, and the other one is speed of stream. So how do we find the speed of stream and the speed of boat in still water? So whenever you have to find speed of boat in still water, you have already found out upstream speed and downstream speed, right? Just add them, upstream speed plus downstream speed, and divide it by 2. You will get the speed of boat in still water. So I have already told you how to find u and d. Now when you add d and u and divide by 2, you will get the speed of boat in still water. Likewise, if you have to find the speed of stream, in place of add, now subtract like this, and you will have the speed of stream. So you can take a screenshot how the method is going to work, because now after this we are going to apply it to solve some questions. Probably the question which I listed down here, this one, we will do this first. So for finding the speed upstream, that is u, I told you we have to do cross multiplication like this, right? So 12 times 10.5 minus, then like this, 15 times 14, and in the denominator you will have 6 times 10.5 like this minus 14 times 6.5. So all the calculations written for your convenience here. And then the downstream speed, I told you the numerator is going to stay the same. So 12 times 10.5 minus 15 times 14, and in the denominator now the situation changes. We have 12 times 6.5 minus the other way around 15 times 6, and this is the calculation which you have to perform now to find the value of u and d. I have already done it for you so that it becomes easy for us to proceed through. This will become 84 upon 28, which will give you the answer as 3 kmph, and this second part will give you 84 upon 12, which will come out to be 7 kmph. So you know that the upstream speed and the downstream speeds have been attained, and now if you want to find the speed of boat in still water, you just have to add them and divide by 2. So 7 plus 3 by 2, which gives 10 by 2, 5 km per hour is the speed of boat in still water. And if you want to find the speed of stream, then you have to subtract. So 7 minus 3 upon 2, which gives you 4 by 2, 2 km per hour is the speed of stream. Now little practice required, and I'm sure this is going to work for you if you solve 10, 15, even 20 questions of this nature. Let's do one more question. Here you can see we again have the same situation where we have upstream 12.5, downstream 18, and a time of 4 hours. So 4, 15 upstream, so 15, 24 downstream in 5 hours. So again we need to find the speed of stream and the speed of boat in still water. So what do we have to do in this case here? To find u, we will start with here, this one, go across like this. So 12.5, 24 minus 15 times 18, and in the denominator, you know what to do? We have to do like this, 24 times 4 minus 18 times 5. This is u, And then to find d, numerator remains the same, 12.5 times 24 minus 15 times 18. In the denominator, the condition changes. So we have to do 12.5 and 5, and the other way around, minus 15 times 4. Now these are the two speeds which we have to find first. I have already found out for you. This is 30 upon 6, which is 5 kmph. And the second one is 30 upon 2.5, which is 30 upon 2.5 is 300 upon 25, which is 12 kilometers kmph. So the downstream speed is more, 12 kmph, and upstream speed is 5 kmph. So now if you have to find the speed of both, what do you have to do? You have to add them and divide by 2. 12 plus 5 upon 2, 17 by 2, 8.5 kmph is the speed of boat in still water. Likewise, speed of stream will be, take the difference this time, 12 minus 5 upon 2. 12 minus 5 is 7, 7 upon 2 is 3.5 kmph. See how wonderfully the trick works and how quickly we can find the solution. As compared to the first question, we have taken very much less time in question number 2. So practice is what is required to, actually perform this in the exam and find the correct answer in the first attempt. So friends, if you're liking all these videos, do share it with all your friends so that they can also watch the beauty of mathematics and the beauty of short tricks. On your social media platforms, you can just click, check the link and post it there so that students can take benefit out of this. And do not forget to subscribe our channel and click the bell shaped icon so that you keep on getting all the notifications of future uploads on your mobile itself. Practice 15-20 questions of this nature and I'll wait for your comments. Is it working for you? All the best.